What's going on, you guys? So we're going to work on best time to buy and sell stock. So say you have an array for which the ith element is the price of a given stock on day I. If you were only permitted to complete at most one transaction, i.e. buy one and sell one share of the stock, design an algorithm to find the maximum profit. Note that you cannot sell a stock before you buy one. Okay, so let's think about this. So I don't know if you guys have seen Back to the Future, but Biff gets a magazine of all the sports results. So he knows when to bet on the winners and when to not bet. So in this case here, like, we have the stock price. It's like Biff. He has the game scores beforehand. And so if we know what the stock prices are going to be, when should we buy and when should we sell? And we can only buy once and sell once. So here's how we're thinking about that. Okay, so we've got this example, 715364. So we have to ask ourselves, do we want to buy on day 0 and sell on day 1? Well, that would give us a current profit of -6. So probably not. We don't want to do that. So we'll set current equal to the max of 0 and current. And so in this case, it's 0. And the most we've seen so far is going to be the max of current and most. And so we'll initiate most to 0. We'll say up here, we'll say most equals 0. Okay, so next day. So do we want to buy on day 1 and sell on day 2? Well, that would give us a current profit of 4. So 0 and 4, we're going to take 4, and then most is going to be max of 0 and 4, so this is going to equal 4. Okay, so we're updating here. So current is now 4. We're going to move up. Okay. Okay, so now do we want to, so current is now 4 plus, if we bought at 5 and sell at 3, so minus -2, we lost 2. So that equals 2. So current equals max of 0 and, in this case, 2, so 2. And most equals the max of current, which is 2, and most, which is 4, so it's just going to be 4. Alright, so we're moving up a day again. So now current is 2 plus buying at 3 and selling at 6, so plus 3, so 5. So current is going to be the max between 0 and 5, so it's going to be 5. And most is going to be the max between 5 and 4, so it's going to be 5. So moving up again. Now 5 plus, if we bought at 6 and sold at 4, that's going to be -2. So that's going to be the max of 0 and 3 is going to be 3. So the max of 3 and 5 is 5. And then we'll just return most. Okay. So we're only going to go through prices once. We're going to look at each item once. So this is going to be an O of n algorithm, O of 1 space. So let's write some pseudocode. So we'll set most equal to current, which equals 0. We don't want to do that. No. We want to do, there we go. Pseudo. Okay, and for I in prices dot indices, let's say current plus equals, we'll add the current prices of I minus the previous day's prices. right? So, oh, and I is going to be, I is going to go from 1 until the end. Okay, so I is going to start, let's call this I. I is going to start at 1, and we're going to add prices of I minus prices of I minus 1 to current. And then we're going to say current is the max of 0 and current, right? Because we can always choose 0. We can say, you know what, we're standing pat, we're not buying today. And so our profit is going to be 0 if we don't buy. And then we're going to set most equal to the max of current and most. And then we'll return most. Okay, so let's convert that to Kotlin. Okay. Clean this up. Anything else? Okay, let's see if that works. All right, you guys, there you go. O of n time complexity because we only stop at each price once, and O of 1 space complexity because we're only using these pointers here. All right, you guys, stay tuned for the next one. See ya.